Hello chemists and welcome to this episode of Bayes' Chemistry. We are going to be working out how to calculate the oxidation state of a metal ion inside a transition metal complex. It's on the AQA Specification 2.5 transition metals and it appears on paper 1 of your AQA final exams. If you haven't already hit subscribe, make sure you do to not miss out on any episodes coming up in the future. So, metal ions. Metal ions are of course transition metals, and transition metals can have variable oxidation states. This means that the oxidation state of the metal ion depends on the ligands that are around it and the overall charge on the complex itself. So we need to know the charges of each ligand. So first of all, we'll look at our monodentate ligands, and we've got ammonia. So ammonia NH3 has no charge on it. The chloride ligand then, the chloride ion Cl- has a negative charge on it, and the water ligand, the H2O, has no charge. So our bidentate ligands then, we've got our ethane 1,2-diamine, and that has no charge on it. And then we have our ethane dioate, and that has 2 negative charges on it. And then our final one is our multidentate ligand, EDTA, and that has 4 negative charges on it. So we'll take a little look at an example of this. Then we'll start off by looking at this cobalt complex where it's got 6 water ligands attached to it. We'll first calculate the total charge of all the ligands. Now there are 6 ligands. They have no charge because they're water ligands, so the total charges of all the ligands will be 0. We'll then look at the overall charge of the complex. We'll read that off the formula, and that is 2+. And then we'll use this quick equation where we take the metal ion oxidation state equals the total charge on the complex minus the charge on all the ligands. So in this case, we're just taking 0 away from 2+. So the charge on the metal ion in this case will be 2+. On a slightly more complicated example, then we'll look at this copper complex with 4 chlorine ligands. Now we know that chlorine ligand has a -1 charge. We've got 4 of them, so overall that would be -4. The overall charge on the complex, then we can read off the formula, is 2-, and we use the equation we used on the last step to calculate that the metal ion has a charge of 2+. Now there are 3 simple steps to make sure you get this calculation right all the time. First off, calculate the charges on all the ligands. Second thing to do is identify the overall charge on the complex given in the formula. And the third thing is to remember this calculation that you have to carry out to work out the metal ion oxidation state. Thanks for watching this really quick video on calculating the metal ion oxidation state in a transition metal complex. If you've enjoyed it, hit the thumbs up below, and don't forget to watch all the other videos on our transition metals playlist above.